All right, I got to cover a lot of topics really fast because frankly I forgot to record earlier. So I'm going to go through a bunch of things really fast that would normally spend more time with. You want to get the clump alone. If you had this problem, for instance, you can't start this problem until you get what off of there? The -1. And this is the clump we have to get alone. Then I can rewrite it once I do that. I get the negative off by dividing by -1, and I get a negative to go over there. Now, how do I rewrite this? It has no base. What is the base then? The base must be 10. And then I can do a rewrite, and I'd say 10 to the -10th power is equal to x minus 4. I did this to the this power equals that. Okay, and then the calculator could help you solve it the rest of the way. You find out with a calculator, then you add 4 to both sides. All right, some pattern ones. 5 to the ln2. Do you have an automatic answer on that one or not? No, because you don't have the two bases the same. What's the base on this right now? E, very good. So if I change this to an E, now what's the answer? The answer's 2, good. Okay, now I'm going to do a quick log base 2 of 32. Because it's a really simple answer. Couldn't you write 32 as 2 to the something? 2 to the 5th. Memorize it. You should know that one like the back of your hand. 32 is 2 to the 5th. So now, what's the answer? 5. Okay. If I set it equal to x, you can see that 2 to the x equals 2 to the 5th. 2 to the x equals 2 to the 5th. So therefore, x must equal 5. Okay, now let's do that application problem I was going to talk to you about. So underwater, deep underwater, are you aware that if you go deep enough that there is no light? Even though it might be a bright sunny day up above, if you go deep enough, all the light's gone. And in this certain super submarine, they have subs that can go deep. They can't go as deep as the deepest spot with humans yet. They have robot subs, though, that can get the deepest part of the ocean. Like right now, they're looking for that flight that crashed somewhere off Australia or who knows where, somewhere. Flight, which one flight is that? 370 or something like that? Anyway, yeah, they want to find it because they just want to know, like, because if they can find it, then they probably can find the flight recorder, and if they can find the flight recorder, then they can get all that data off of it. But there is all kinds of, questions, like, were the people that were, what did the pilot do that was flying it all over the place? Like, were the people that were on the flight, could he have killed them? Do you know how he could have, the pilot? Cut off their oxygen, depressurized it. He could have killed all the people in the plane if he wanted to. Then he wouldn't have anybody bothering him, so to speak. Not saying he did. We don't know, though, right? He could have. Yes, sir.
Why is that an option?
It shouldn't be an option. Really, all it is they can depressurize the plane. So they have the ability to control the pressure that's in the cabin. Really, if you think about it, they don't try to, like, prevent the pilot from having, like, the ability to kill the passengers because he's the pilot. They got to trust him, to start with. If you don't trust the pilot, he could just crash it anytime he wants to, especially on takeoff or landing. It'd be easy. But anyway, they're trying to find that thing deep underneath the ocean. Underneath the ocean, there is very little light. So we're going to say L is lumens, and we're going to go 10 times log of x minus 4. Let's say that function right there is a function where L is the lumens. That is a measure of light. You can buy light bulbs, and it'll say this light bulb will give off this many lumens. Just so you have an idea of how big a lumen is, a lumen is the amount of light that would be shined onto a surface that's 1 square foot in size by a single candle. So it's how much light is coming into that one surface from that single candle. That's considered 1 lumen. So if you needed to illuminate a 1 square foot piece with a candle, that's 1 lumen. Most light bulbs are going to be like 5,000 lumens, or a fairly large number of lumens. All right, anyway, if L is the lumens and X is the amount of square feet of window space on your super sub, then explain to me What happens if you have only 5 square feet? On your super sub? How much light is that going to let in? This brings up another important pattern. I'm going to take a second and remind you of this one. What's the answer to that? Automatic answer. I have won the argument, and therefore the answer is 0. I'm going to go back to this now. What happens when I put a 5 in? You get a 1 where? In the argument. You won the argument. What do you get? 0. 0 times 10 is still 0, isn't it? What's the point? The point is the lumens would be 0. If you have 5 square feet, that's not enough to let in enough light to make it work. Yeah, you'll have no light. This formula obviously would break down if you put in a number like 4, because then if I put in a number like 4, 4 minus 4 is 0. Log of 0 doesn't even exist. Like, what is the answer to this question? Log base 3 of 0. What do you say? Undefined. Very good. Same thing if I change it to a 10, then it'll be all right, but how about if I make the base negative? How about now? Undefined. Okay, good. Back to this formula. If I use a number like 4, it's not defined. So we'd have to have a domain for this. We'd have, in that pre-calc, we talk a lot more about this. You'd have to say, well, your domain is that x has to be 5 or bigger. Otherwise, this formula just doesn't work. Do you remember the domains on those other ones that were like n has to be greater than 3? You know what I mean? Or we had a lot of n is greater than 1 on the domain. It just means that the problem won't work if it's smaller than 1. This problem won't work if it's smaller than 5. 5 square feet gives you a 0 lumens, as in if you're underwater and you have a 5 square foot thing, you're not letting in enough light to even be like 1 candle of light. But if I increase this to like 50, then you can figure out how many lumens that is. So everybody try changing this to 50. Put in 50 into the equation and see what you get. Question? Yes? The argument cannot be negative, neither can the base. Think of it this way. They both have to be positive. That means they can't be 0. The base and the argument both have to be bigger than 0. 0 is not good and negatives are not good. I'm going to be going to lunch soon, so try to get this done. Yes? It's a good question. We want it to be greater. We want our domain on those is that both the argument and the base need to be greater than 0. Because I don't have that answer right off the top of my head. I'm not sure. All right, so you should have put a 50 in here, which means you'd have 50 minus 4, which would be 46. Log 46, and then you just times it by 10. Raise your hand if you have the answer. All right, Miss H, what did you get? Can anybody verify that answer? Raise your hand if you're the same as them. Okay, good. Then that's probably it. All right. What does that mean? 16 lumens. If we got 50 square foot window, that's pretty big. 5 foot by 10 foot would give you 50. That's a pretty big window for a submarine. And you're still only getting the equivalent of 16 candles of light, which is not a lot of light coming into that room from that big opening. All right, this is not a real formula that actually works, but it's an example of how you might have this kind of problem as an application question, and you just have to figure out where to stick the number. What if your evil genius boss says, I want, on my submarine, I want it to give off 20 lumens? Oh, what would you do? Where would you put the 20? And you'd have to tell him how many square feet of light, square feet of windows he's got to do if you put the 20 here. How would you do that? Well, you got to get the clump alone. See, that's the clump. We got to get that clump alone, so we divide by 10. And then I've got 2 equals log of x minus 4. And then, how am I supposed to rewrite it if it has no base? Well, it has a base. What's the base? Base is 10. And then I can rewrite it, and what would it be? 10 to the second equals x minus 4. From there, it's just 10 squared is 100, and then you add 4 to both sides. X equals 104. What does that mean? You'd have to tell your evil genius boss that he needs 104 square feet of windows then if he wants 20 lumens. Okay. Before we head to lunch, I want to remind you that your main job is to prepare for this test, and there's a lot of good Schoology quizzes you can do to practice, and the one I want you to do in class after you come back is the last one in the list. It's called Logs Test Review. There's like 4 or 5 of them in there. We already did 1 or 2 of them, but today only want you to do that last one, Logs Test Review. Okay, lunchtime. Okay, we're just back from lunch. I know you got to kind of try to switch gears, but please get into Notability. And blank page, and let's talk notes on graphing for just a minute. All right. Do you get that the log graph parent kind of looks like that? Remember how I described it as kind of like a tree having blown over in the wind? And that's what a log is a tree that blew over, right? Okay, so where's the asymptote on that thing? Visualize where it should be, and then see if I draw it in the same place you think. A lot of people do get confused in this one. It's right there. That's where the asymptote should be. Okay, good. It's not the other way. The other way does grow forever, so we could not draw an asymptote in like this because it doesn't stop growing. It would go across the line, so to speak. So anyway, this is your typical graph. Now, what if I shift it to the left? Would the asymptote move also? Yes. How about up and down? Would the asymptote move then? No. Okay, so if I describe this as, okay, I'm going to move this up, I'm going to move this to the right, it's only to the right part where the asymptote would have to move. Okay, so one of your homework questions is kind of like that. All right, now let's talk about what if you had a complicated one and how would you graph it? Y equals log base 3 of x minus 4, and I'm going to throw a negative in front of all that too. Well, the parent one goes back to this. That's the parent one. And now, does the order of this thing matter? Yes, it does. Got to be careful with that. Now, I suggest you start on the inside. So what does this right there tell me to do? Right 4. So I go over right 4. There we go. Done with that. Now what? A negative on the outside. Is that an up, down, or a left, right? Some of you are not with me. Stay with me, please. All right. Then up, down, flip would look like this. Does that make sense to you? Then the question might just ask, where is the asymptote at the end of the problem? What would the answer be? Okay, where is that? There's a specific answer, and the answer is not 4. X equals 4. X is an up-down thing. So the y-axis is x equals 0. That's x equals 4. The asymptote would be x equals 4. Okay, now how about if we had to make an XY chart for this thing? These are tricky, but they're not impossible. Remember how I've said I want you to have 2 points? The smart thing to do is to try to make this part right here equal the base. And also make that part right there equal 1. Because if you won the argument, then you'll get what? 0. And then if you make this equal to the base, if this is like, let me think, a 7 by 4 would make it 3. Do you get how if there's a 3 here and there's a 3 there, the base is the same, the answer is 1. But then a lot of people forget the negative in front. So the answer, if I put in a 7, I really get what? Negative 1. Okay? Now 7, negative 1, do you see how 7, negative 1 could be on this graph? Does that make sense? And how about the other one we did, which would be to win the argument? If you make that 1, you'd have to put in a 5 for the x to do that then, right? 5 minus 4. So 5, we can make this 1 the argument, make it 0. Negative 0 is still 0, 5 comma 0. And there we go. There's 5 comma 0. All right. Anyway, that's... I didn't make it to the right scale and everything, so I could be off a little bit, but that's basics. I got 2 points. I got the asymptote in the right spot and generally in the right direction. So that green line's my final answer. And is the XY chart required? We want 2 exact points. So if you don't want to do an XY chart, then you got to label this and say this point right here is 5, 0. And this part right here, point right there, is 7, negative 1. If you want to do that instead of an XY chart, totally fine with me. That's the basics of graphing. What if you had to graph one that was an exponential? Seven to the x. Do you remember what an exponential looks like? Think about exponential growth. That's an exponential. An exponential and a log are exactly reflections of each other over that line. Do you get how those are a reflection across that line? They're a reflection across the line y equals 1. Again, just a rough sketch here, but these are inverses of each other. So if I had 7 to the x, if I rewrite that puppy as a log, I'd say log base 7 of y is equal to x. And inverses are where x and y get rearranged. And so if I rearrange the x and the y, I'll have y equals log base 7 of x. So that's why this and this are actually inverses of each other, and they look like this and this. Okay, so graphing. Let's just give me 2 good points on this one. Don't even think about where it is yet. Just find me 2 good points. If x is this, y would be that. And find me another one like that. Write them down on your iPad. And turn them my way, and I'll tell you if you found good combos or not. To add to my list of fun sayings that I like to say, if you win the argument, you get nothing. So what I mean by that, that's the argument right there. How can I make that 1? If you won the argument, make it a 3. If x is 3, I'll win the argument. I'll have a 1 in the argument, and then I will get 0. 3, 0. Raise your hand if you had that one. Okay, good. And the other one, who's got it? Yes, sir. 8 goes in. I agree. 8 minus 2 is 6. Log base 6 of 6 gives you what? Again, this comes out to log base 6 of 6, which is what? All right, 8, 1. Raise your hand if you had 8, 1 on your list. Good. Those are 2 good points. Now, if you wanted, there's other points you could pick. If you made this whole thing equal 36, you get how that's 6 squared? So how could I make this 36? I could make it actually 38 for x. Now, what's wrong with that? It'd be like impossible to graph 38. But anyway, if I put in 38 right here, 38 minus 2 would be 36. And then that's really like 6 squared. And so the answer to that would be 2. All right. There's other points too. You could go for the 1 over the base thing, but then you got to get x minus 2, this part right here, to come out to 1/6, and that's a bit of a pain. So, okay, I think that's all I need to do with you. Now you can have the rest of the time to do that little Schoology quiz. I know it's a little more than usual for homework, but tomorrow is a big test, and I just don't want to cut it down much. The only homework problem I'd have you skip is J, as in Jingle Bells. I think there's only one J on the whole sheet. So, oh, the quiz is the one that says test review. Specifically, it says test review on the word after the Schoology quiz thing. You see the one that says test review? Okay. I guess it's 5, is that? Okay. Okay. That's all I have for the video for today. You can always come in the morning if you want help. I'll be here at 7:10 in my room, 1430. I'll be happy to help. Actually, I'm going to just keep helping just a little bit here and help you with the very first one on the Schoology quiz. Would you read that to me?
Yeah. Possum population.
The possum population is 5,000 what?
100.
Okay, there's 5,100 of them, and it's growing at what percent?
5.6.
5.6%. And what do they want to ask about ending at? Like double. Double 5,100 would mean it starts at 5,100 and it ends, our problem ends anyway, when it hits 10,200. How do you do that? I'll remind you. Do you remember when we had like $5,000 invested at 1 plus 0.06 and we wanted it to grow to 10,000? Remember that kind of problem? It's just like that, except it's possums. So how many possums do we have? 5,100. And then how many do we end with? 10,200. And then that's your rate, except you got to fix it for this problem. And then how do you solve it? You get the clump alone. That means to get that alone first. So you're going to divide by the 5,100 and get the clump alone. Then you'll be able to rewrite it. These are hard to see all the way to the end, but I'm not going to show you all the steps. So you have to figure it out from here. But I got it set up for you. And again, you got to change that to the right rate. Okay, that's the one I wanted to help you with. Now I'm actually really done with the video.